Now we're going to do the 2015 question 3 that came up in paper 2. And what it says is the coordinates of 2 points. So we have point A, which is 4 minus 1, and point B, which is 7t. So there's 2 points, and the line L1 is perpendicular to AB. Find the value of t. Well, if one line is perpendicular, so if I want to get the slope of, so I have my line L1, if I want to get the slope of that, I can write it in terms of y equals mx plus c. So then minus 4y is equal to minus 3x plus 12. So we just want y by itself. Or minus y we'll get first. So minus 3 over 4x. And then plus 12 over 4, so plus 3. And just to get y then is 3 over 4x minus 3. So the slope of line L1 is 3 over 4x. So the slope of a perpendicular will have to multiply by that to give minus 1. So it will be minus 4 over 3. So that's the slope of AB. So to make the equation of a line, we need the point and a slope, and then we can sub it into y minus y1 is equal to x minus x1. So we know point A, so we'll use that point to get the equation of our line. So y minus minus 1 is equal to m, which is the slope. Sorry, I should just put in the value of the slope, x minus x1. So y plus 1 is equal to minus 4 over 3x. Sorry, it should be x minus 4. So then I'm going to multiply both sides by 3 to get rid of my fraction. 3y plus 3 is equal to minus 4x minus 4. So then I'll just do out my bracket on the other side. So minus 4x plus 16. So then if I want to get everything on just one side, might be easier. So 4x plus 3y plus 3 minus 16 is equal to 0. So 4x plus 3y, so that would be minus 13 is equal to 0. But now I was asked to get the equation of, I just wanted to get the value of t, but I know that b lies on this line AB, so I can just sub in x equals 7 and then y equals t and subsequently solve for t. So sub in x equals 7 and y equals t minus 13. So now I'm just going to solve this. So 4 7 is 28 plus 3t minus 13 is equal to 0. So 3t, and then it's just going to be plus 15 is equal to 0. So 3t is equal to minus 15. So t is equal to minus 15 over 3, which will be minus 5. And t is equal to minus 5. So now we have our value for t, and now it says find in terms of k. So just go on to find in terms of k, so the distance between the point. So we want the distance between the point 10k and L1. That's 3x minus 4y minus 12. So that's the perpendicular distance from a point to a line. So the perpendicular distance, if we get from our log tables on page 19 in our log tables, plus c, and it should also be in your book, so a squared. So when we have an equation like this, the point we label x1, y1, and then the line, the x coordinate is a, so a equals 3. The b coordinate, the b is the y coordinate, the y point, so b is minus 4, and the c is just doesn't have a letter attached to it, so the c is minus 12. So if we're going to sub that in, so a is 3, x1 is 10, so b is minus 4, y1 is k, and then plus c, which is minus 12, all over. So a squared is 3 squared, which is 9, then b squared is minus 4 squared, which is 16. So then if I just tidy this up, so 30 minus 4k minus 12, all over, so 9 plus 16, which is square root of 25. Then if I just tidy this up a little bit, it's going to be minus 4k plus 18 all over 5. So it just has to have, in terms of, or we could have 18 minus, so in terms of k, we just, it's just going to be in terms of k. So that's as much as we can do for the moment. And then, so that's that part of the question. And then it says the point 10k is on a so our lines L, so I'll just write down what we know for already. So L1, the equation of this is 3x minus 4y minus 12 is equal to 0. And then, so that's just something that, so, and L2, it says 5x plus 12y minus 20 is equal to 0. And what we're just after figuring out is the perpendicular distance. So these are just a piece of information that we know already. The perpendicular distance from 10k to L1 is, so minus 4k 18 over 5. So that's the perpendicular distance from k. So that's information that we know already. So that's a kind of our little bank of information that we're going in with. So it says that 10k is on a bisector of the angles between the lines L1 and L2. Find the possible values for k. So, well, I don't know exactly what my lines L1 and L2 look like, but say if they coincide something like this, they're just going to intersect somewhere, one line versus another line. And then it says that 10k is on a bisector of these angles. So half in the middle of this angle, there's another line which 10k is on. 10k is on so say 10k is somewhere, it could be here, it could be here, I'm not sure, but it could be anywhere, but it's on a bisector, a line that bisects. Bisects means halves the angle. So that means if that's halving the angle, well then the distance from here to here is the same as the distance from here to here. So the distances would be equal. But I already got the distance from the line 10, from the point 10k to L1. So maybe if I now get the distance from the line 10k to L2 and let them equal 10k to L2. So the perpendicular distance is, from our log tables, ax1 plus b, y1 plus c, all over, a squared plus b squared. So our line L2 is 5x plus 12y minus 20 equals 0. So a is equal to 5, b is equal to 12, and c is equal to minus 20. So if we're just going to sub that in, and then this is x1, y1. So a is equal to 5, and then that's a x1, so 5 by 10. B is equal to 12, so 12 b by our y part, which is k. And then c is equal to minus 20. All over a squared, which is 5 squared, which is 25, and then plus b squared, which is 12 squared, which is 144. So now I'm just going to write this in simpler terms. And just 1 second. I'm just going to, so what I had was this. So 5 by 10 will give us 50 plus 12k minus 20, so the modulus of that, and then we have 25 plus 144, so the square root of 169. So then I'll just tidy that up a little, so it'll be 50 take 20 plus 12k, and then the square root of 169, which is 13. So this is a distance from, I'm not sure if this is actually what it looks like, but it's going to be two lines and the half. So the distance from, we get the distance from, say this is the point 10k. we get the distance from 10k to one of the lines and the distance from 10k to other lines, and let them equal. We'll have two equations in k. So the distance that we first got was minus 4k plus 18 over 5, and the distance that we got from the point to the second line was 12k over 13. So, and we are asked to find the possible values of k. Well, what I think we might do first is, well, we can, well, what we could do is we could square both sides, if we like, we can square both sides to get rid of the modulus. So then if we square this side, it'll be minus 4k plus 18 over 5 all to be squared, and then is equal to 30 plus 12k over 13 all to be squared. So then if I want to sort this out, so then it'll be 4 squared, so that's just that by itself. So 4 minus 4k will be 16k squared, and then 4 by 18k will be minus 72k, and then we have 18 by minus 4k, which will be minus 72k, and then 18 by 18, which will 18 by 18, which will give us 324, and that's all over 5, and then that's equal to, so 30 squared, so it'll be 900, and 30 by 12, so 360, and there'll be two of them, so plus 720k plus 144k squared. Oh yeah, I'm sorry, we had to square the 5 on the bottom here, so it's a 25, and then we square our 13 on the bottom, so it's 169. So if we just want to try and get somewhere with this, so it's a bit complicated having to square out both sides. So say if we just tidy this up a little, so 16k squared, so 72 and 72 will give us minus 144k plus 324, and that's over 25, and then that's equal to 900 plus 720k plus 144k squared all over 169. So I'm going to get rid of my fractions, so I'm going to multiply 169 by this side, so 116k squared 144k plus 324, and 25 by my other side, to get the common number on the bottom, plus 720 plus 144k squared. So 160, we're gonna get quite big numbers here, by 16, so that's 2704k squared. 169 by 144, so that's minus 24336. 169 by 324, so that's getting quite large numbers. So then I'm going to write equals, and I'll do the part on the second line. So 25 by 900 is 22500. 25 by 720 will be 18,000k, and then 25 by 144 will be 3600k squared. So now I'm in a position where I can get everything onto the one side. So I have so my k squareds and my k squared. So I might bring this over to that side. That'll be 3600 take 2704. So that's going to be 896k squared. So then I've dealt with my k squareds, and then I have dealt with my k squareds. So then the next thing I have to do is deal with my k's, and this is a k here. Sorry, I just haven't put it in. So this k, and we have k here. So if we bring everything all over to this side, it'll be 18,000k plus 24336. So that'll be plus 42336. Okay, and then so 2 to 500, take 54756, and that will be minus 32256 equals 0. So what I want to do now is kind of get this a bit more easy for me to deal with. So firstly, everything divides by 2, so I'll just for handiness check if we can get everything won't divide by, so we can divide, let's see, can we divide 896 by 4 and 896 by 6? So we can divide everything by 8, maybe 40, just to get everything a bit easier for us to deal with. 2, 2, 5, 6 divided by 8. So we can divide everything by 8. So 896 divided by 8. So that will be 112k squared plus 42336 divided by 8. And that will be 5292k, and then 32256 divided by 8. So that's minus 4032 equal. Now we could use the minus b's formula here, but I'm just going to see if I can divide across by something again. So 52 2 divided by 16. So just checking if I can get it a bit easier. So 4032 divided by 8. So 5292. So I'll just divide everything. Won't divide by 8 again. So I'll divide everything by 4. 1323k. So 112 divided by 4. So that's 28k squared. 4032 divided by 4. And then that's minus 1008 equals 0. So we're going to have to use a minus b. So it'll be minus, this is minus b, minus 1323 plus or minus. So 1323 squared minus 4a, which is 28, and then c, which is minus 1008, all over 2a. So I'll just work under my square root. So I have this 1323 squared minus 4 by 28 by minus 1008, and that is, so I got a large square 1863225, so that's minus 1323 plus or minus, and all over 28 by 2, which is 56. So then if I want to get the square root of 1863225, so I get 1365. So it's minus 1323 plus or minus this all over 56. So now I want to get so that's what k is equal to. So now I want to get just actually work out. So 1323 minus that over 56. So minus 1323 minus 1365 over 56. The first answer I get is k is equal to minus 48, and then when I plus I get k is equal to 3 over 4. So my two answers I could have got was k is equal to minus 48 and k is equal to 3 over 4. But I didn't realize how long that was going to take after I squared it. So another option that I could have taken was I could have had, so I just explain this to you in case you're in a situation and you're struggling a bit with algebra and it doesn't seem like a great idea to multiply out. So say if it's a modulus, that means that so if we just want to maybe get rid of our fraction first, so the 5 on the top, we move it to this side. So 5 by the modulus of 30 plus 12k is equal to 13 by the modulus of 18 minus 4k. And well, whatever answer we get, we also have to take the positive version, and we have to take the because the modulus, if we're dealing with modulus, we're looking for the values of k. So whatever answer we get for this, we have to take the positive value. We have to say that this is equal to plus that, or it's equal to minus that. So the first thing we do is we let 13 by 18 minus 4k equal plus 530 plus 12k, and we let 13 by 18 minus 4k equal minus 5 by 30 plus 12k. And I think that would be a simpler answer, and you'll get the same answer if both ways. And then it says that k is, so then the part 2 says that k is greater than 0. So k is greater than 0. So the two answers we got for k was k is equal to minus 48 and k is equal to 3 over 4. So if k is greater than 0, that means k is going to be 3 over 4, and it's not going to be minus 48. So we're asked to get now the distance from P to L1. So we got the distance from P to L1 in the previous part. So we got that it was 18 minus 4k over modulus of that over 5, and we're saying that k is equal to a quarter, so it'd be the modulus of 18 minus 4 by a quarter k over 5. So that's 18. So 4 over, so that'll be just minus 3. So the modulus of that over 5. So that'll be just 15 over 5. Sorry, 15 over 5. So that'll be equal to 3. So 3 is the distance from P to L1. And then if we just have a look at the next part, so the next question in 2015 is also a geometry question. So I'll just compare this. So it says 2 circles. So we have 2 circles here, and so 2 circles. So we have B, we have K here. This is circle C, this is circle S, and this is the center of B. So 2 circles touch internally at B as shown. The equation of circle S is, so x minus 1 squared plus y plus 6 squared is equal to 360. So we know that circles are going to be in the form x minus h squared plus y minus k squared is equal to r squared if the center is hk. So that means the center of this circle would be 1 minus 6. That would be the center of this circle. And if we wanted to get the radius of this circle, well, we'd have to get the square root of 360. So the square root of 360, and we get 6 root 10. So the center of our circle S is equal to 1 minus 6, and then the radius is equal to the square root of 360, which is equal to 6 root 10. So then it says the point K so the point K is, so we see our point K is in the circle of C. So we see the point K, so this is our circle. C is a smaller circle, S is a bigger circle. The radius of C is 1/3 the radius of S. So find the coordinates of B. So it tells us the coordinates of B are 7, 12, and so we're after getting the radius of S, and that's 6 root 10. So 6 root 10. So it's handy to have our diagram here. So, and we got the coordinates of the center of C, which was 1 minus, center of S, which was 1 minus 6. So if we just look at what we have here, so we have that the center of S is 1 minus 6, and then the radius of S is 6 root 10. And then we're told the radius of C is 1/3 the radius of S. So 6 root 10 divided by 3, and then we get 2 root 10. So the radius of C is 2 root 10. And then we are asked to find the coordinate of K. Well, if we wanted to find the coordinates of K, well, what we could say is we could, say if we have from B to K to the center of the bigger circle, do they give us the point? So let's just call this A. So A is 1 minus 6. So B is 7, 12. And it's in a straight line here. So say if we can use translations if we want, or we can divide this line. So it says this, so if this is from A, if this is 1/3 of the radius of the other one, well then this would be in the ratio 1, and then this would be in the ratio, so that would be 3:1. So that would be dividing a line in a given ratio. So if we could divide our line in a given ratio if we want. So we're looking to get this point here. So then if that's 3 and that's 1, well then here to here is 2. So we're dividing our line in the ratio 2:1. And if we look at the point, we can get the equation to divide it be px1 plus ax2 all over b plus a. And then this is in our log tables, page 18. This is dividing a point in a given ratio. So the ratio we're dividing is 2:1. And our first point is 1 minus 6. And we're looking for, and the second point is 7, 12, and we're looking for the midpoint. So A is equal to 2, 1 is equal to B, and then this is x1, y1, x2, y2. So B is 1, and then x1 is 1, A is 2, x2 is 7, all over B plus A, which is 3, and then B is 1, y1, which is minus 6, and then A is 2 and y2, which is 12, all over B plus A, which is 3. So that's 1 by 1, which is 1, 2 by 7, which is 14, over 3, and then minus 6 plus 24 over 3. And then what we can do is, so that's going to be 15 divided by 3, which is 5, and that's going to be 18 divided by 3, so that's going to be 6. So our point is 5, 6. Or we could have said, well, the distance from 1 to 3, from this to go to 7, 12. So that's 3 out of 3. But say if we just want to go 2 out of 3. So from this to go to here, we plus 6, and then we plus 6, and then from here to go to here, we plus 18. Well, if that's 3 out of 3, if that's, say, from here to here, that's 3, say if we divide it into x and x, well, that's 3x, and that will be going up 3x. But if we only want to go up 2 points to get to our middle, well then, if 3 movements, let's call x kind of a jump, 3x is 6, and 3 for y jumps is 18. Well then, if we just want to get one jump, will be 2, and one jump for our y will be 6. Well then, 2 jumps will be plus 4 and plus 12. So then we have 1 minus 6 plusing 4 on the x, which will be 5, plusing 12 on the y, which will be 6. So we get the same answer either way. So that's with translations, or we can do it by dividing the line in a formula. So then we're asked, the next thing that we're asked to do is find the equation of C. So, well, the equation of C is going to be relatively easy to find because we know that 5, 6 is the center of C, and the radius of C we got was 1/3 the radius of the other one, which the radius of C was 2 root 10. So if we want to sub that into x minus h squared plus y minus k squared equals r squared. So then x minus 5 squared plus y minus 6 squared equals r squared, and then if we just want to square 2 root 10, we shall get an answer of 40. So that's the equation of our small circle C. And then what it asks us to do is find the equation of the common tangent at B. So the common tangent at B is, so we want to get the equation of the common tangent. Well, that would be this tangent here that cuts both circles at B. And if we want to get the equation of the tangent, well, the first thing we're going to need is a point at the tangent equation of a line. We need a point and we need a slope equation. We need a point, and we have a point, which is 712, and we need a slope. So, but the tangent is going to be perpendicular to the slope of the radius to the tangent, this radius to that this center to that tangent, or that center to that tangent. The tangent slope is going to be perpendicular to the slope, say from the radius to the tangent. So it's going to cut at a right angle. So if we get the slope from say the bigger radius of the bigger circle, we can pick either, but say if we go from the radius of the bigger circle, which is 1 minus 6, and I want to get the slope of that to 712. So then that'll be y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. So y2, 12 minus y1, so minus 6 over x2, which is 7, minus x1, which is 1. And then, so that's going to be 12 plus 6 over 6. So that's going to be 12 plus 6 will give us 18 over 6, and then that's going to give us a slope of 3. So the slope from the center of our circle to the point 712, where the point of tangency is 3. So if the slope from here to here is 3, and perpendicular slopes multiply to give -1, well then the slope of our tangent will be -1 over 3, because if we want to get the slope of perpendicular, the slope of one thing, 3 by -1 over 3, if we multiply them together, we'll get -1. Perpendicular slopes sorry, that shouldn't be a not equal. So multiply 2 equal -1. So -1 over 3 would have to be our slope. But we just need a slope and a point, so then we can sub it into the equation. Y minus y1 is equal to x minus x1. So we know that the slope m is -1 over 3, and our point at B is 712. So y minus 12 is equal to -1 over 3 x minus 7. Just going to get that a bit tidier, so maybe multiply both sides by 3. So 3y minus 36 is equal to -1 by x minus 7. So 3y minus 36 is equal to minus x plus 7. And maybe if we get everything on the same side, that will be equal to, so x plus 3y minus 36 minus 7 is equal to 0. So x plus 3y minus, so that'll be minus 43 equals 0. And that is the equation of our tangent. So it looks something like that would be our tangent. And so I think that is and they just want it in the form ax squared ax plus bx plus b, so that'll be so they wanted it in that format. So that is the equation of our tangent, and that I think is the end of that question, and I hope you find that helpful. Thank you.